looking at notes DD-3, geometric sequences. So geometric sequences are created by consistently multiplying. So look at this sequence we have here. It goes 2, 10, 50, 250. So how is this sequence created? So if you notice, it's created by taking the previous term and multiplying by 5 to get the next term. So take this term, multiply by 5, take this term, multiply by 5, etc., etc., etc. So that 5, what you're multiplying by to get to the next term, is called the common ratio, or in other words, R. So how do you find R if it's not so obvious? So you would take two subsequent terms, meaning terms right next to each other, like 50 and 250, or 10 and 50, or 2 and 10. So you would take two subsequent terms, and you would divide the second by the first. So let's look, for example, take 250 and 50, those are subsequent, they're next to each other, okay, and divide the second by the first. So 250 divided by 50 would give you 5. Similarly, take 50, the second, if you choose these two, 50 divided by 10 would give you 5. Same here, 10 divided by 2 would give you 5. So if you can't just outright see R, then you can use that knowledge to find R. So the formula for geometric sequences, the explicit formula, is as follows. A sub n equals a sub 1 times r raised to the n minus 1. So you probably already noticed that this is an exponential type equation. So remember that when talking about exponential graphs, we had either the growth situation or the decay. And as you know, that has everything to do with that r value, that common ratio. Are the values going to be growing exponentially? Is the r greater than 1? Or are the values going to be decaying exponentially? Is that r somewhere between 0 and 1, but not including 0 and 1? Okay, so that is dependent upon the r value, of course. So today all the problems are coming from the book, so I'm going to try and switch back and forth nicely so you can see the problem, and then back to the paper so you can see the work. So we're working on page 595, number 13 is our first problem. So here's page 595, and number 13 is our first problem, so right here. So in exercises 7 through 16, determine whether or not the sequence is geometric. If it is, find the common ratio. So again, number 13. So notice the first value is 1/8, then 1/4, then 1/2, then 1. Okay, so we're going to go ahead and write that down. So 1/8, 1/4, 1/2, 1. So 1/8, comma, 1/4, comma, 1/2, comma, 1, and then dot, dot, dot. Okay, so is this a geometric sequence? Well, you tell me. To get to the next, do you notice a pattern? Okay, I notice that you could say to get to the next, you're multiplying by 2. Multiplying by 2. Multiplying by 2. Okay, so if you were unsure and you didn't know that that was what was taking place, then remember, you can pick two subsequent terms. So let's just take the first two and divide the second by the first. So that would look like 1/4, the second divided by 1/8. So remember, you would multiply by the reciprocal, so multiply by 8/1. Okay, and then you would have this right here is both of these numbers, 8 and 4, divisible by 4. This would go in twice here, once here, so then our answer, of course, would be 2. Okay, if you wanted to check another set, okay, you could take, say, 1 divided by 1/2. You could take 1/2 divided by 1/4. You could take any of these sets to check it. Again, if you wanted to. Of course, they all have to work out to be true, but hopefully you can see by now that to get to the next, you're always multiplying by 2. So let's just take another. How about 1 divided by 1/2? So those two subsequent terms, take the second divided by the first. So 1 divided by 1/2, remember, multiply by that reciprocal, so 2 over 1. And again, 1 times 2 over 1 is going to become 2. So as we assumed and imagined and predicted, 2 is our common ratio. So yes, this is geometric, and R equals 2. Yes, it's geometric, and R equals 2. Okay? So then our next problem is problem number 25 from the same page. So let's look at problem number 25. So problem number 25 is right here. So in exercises 25 through 30, write the first 5 terms of the geometric sequence, find the common ratio, and write the nth term of the sequence as a function of n. So in other words, that just means write your explicit formula, a sub n. So find the first 5 terms and then write the formula. So on 25, we have a sub 1 equals 64, a sub k plus 1 equals 1/2 a sub k. So we'll write that down. So 25 is a sub 1 equals 64, comma, a sub k plus 1 equals 1/2 a sub k. So to get to the next, you're multiplying that previous term, remember that's what that means, the previous term, by 1/2. So remember that this is called your recursive formula. Recursive formula. Because to get the next term, you always need the previous term. Okay, so let's do like the book said and get the first 5 terms. So obviously the first term is 64. Then if you plug in 64 here to get the next term, you would take half of 64. Half of 64 would be 32. Then you take that previous term, plug it in here. A half of 32 would be 16. Then of course you'd be taking a half of 16, which would be 8, and a half of 8, which would be 4. So that's the first 5 terms, like the book asked for. So first 5 terms, let's talk about R. Okay, so what's that common ratio? So to get to the next number, the next term, we are multiplying by a half. So R equals a half. That's our common ratio. Now, let's write our formula. So a sub n equals that first term, 64, times that common ratio, 1/2, to the n minus 1. Okay, and in this case, we are not going to clean up. This is it. Okay, that's our final answer. Okay, for our recursive formula, or excuse me, explicit formula. Recursive is what was given. Okay, so that's number 25 in the book. Now we're going to do number 31, part B. Okay, so 31, part B. So in exercises 31 through 38, find the indicated term of the geometric sequence, not part A, but part B, algebraically. So 31 is that a sub 1 equals 6, R equals 1/3, and we want the 12th term. Okay, so a sub 1 equals 6, R equals 1/3, and we want the 12th term. Okay, so we have our formula. So up here, a sub 12 equals, our first term is 6 times R 1/3 raised to the n minus 1, so 12 minus 1. Okay, so then you would have a sub 12, plug this in the calculator. Okay, using that scientific calculator, plug this into the calculator first, 1/3 raised to the 11th. Find out what that value is, multiply it by 6. Okay, and you should get 2 divided by, you should get this fraction, 59,049. Okay, last problem, number 41. Okay, on number 41, the directions here. In exercises 39 through 42, find a formula for the nth term of the geometric sequence, then find the indicated term of the geometric sequence. So, let's cover this. Okay, so 41. So we want the 10th term where it goes, the sequence goes 5, 30, 180. Okay. So we want the 10th term, and the sequence goes 5, 30, 180, etc. Okay, so a sub n should equal 5, that's our first term, our common ratio. Okay, to get to the next, what are you multiplying by? Obviously, a whole number, right? Not a fraction that's less than 1, because we have a growing sequence here. So 6, if you haven't already noticed, multiply by 6 to get to the next. That's our r. N minus 1 would be our formula. Okay, we want the 10th term though. So it would be a sub 10 equals 5 times 6 raised to the 10 minus 1. Plug that sucker in your calculator, you get a sub 10 equals 50 million, can you believe it, 388,480. That would be your final answer.